Okay, so looking at linear equations. In this case, for my system, my first equation here is y equals 1/3 x minus 3. Now I'm going to add a second equation to that. The second equation is going to be y equals 5x minus 3. So I need to graph this second equation over the top of the first one so I can see where they intersect. So very carefully, I'm going to come in here, and I'm doing this on patty paper. You don't have to do it on patty paper. I'm just doing this so that I can show you a couple different examples. So my y-intercept here is at -3. So I'm going to come down here and plot my y-intercept at -3. And then my slope is 5. So that's going to come up 1, 2, 3, 4, 5, and over 1. And 1, 2, 3, 4, 5, and over 1. And then I'm going to use a straight edge. It's going to be really important that I actually use a ruler to do this, so that my answer is precise. So I have my first equation and my first line. Now I have my second equation, and I have graphed the second line, and it looks like the point of intersection is right here at 0, 3. -3, sorry. 0, -3. You might have even seen that coming when I plotted here the little y-intercept at -3. So that's my point of intersection. This is the point that makes both of these equations true. And if I'm going to say that's the point that makes both equations true, I kind of need to really prove that that's the case. So always, whenever we're solving systems of equations, we're going to do a check. So I'm going to have my y equals 5 times x minus 3. And in this case, y is -3 and x is 0. So simplifying this, I have -3 equals 5 times 0, that's just 0. So then I have left -3. Does -3 equal -3? I certainly hope so. On this side here, I have y equals 1/3 times x minus 3. And then again, I'm going to fill in my x and y values for that. So my y value here is -3. My x value is 0. So simplifying, I have -3 equals 1/3 times 0. That's just 0. You'll notice I'm not saying the word cancel. I'm saying specifically that this is 0. And I think that's really important, because sometimes when we draw this line, it's 0, sometimes it's 1. So I think it's really important to say what it actually is. And in this case, it's 0. And then so we're left with -3. So I end up with -3 equals -3. So both of those check. That means that 0, -3 is in fact my solution. I'll put it right back where it's supposed to be now. There we go. But this point is my solution for these two equations. Using another example, this time I'm going to look at y equals -3x plus 2. So to plot this one, I'm going to start at +2, which is right here, 1, 2. That's my y-intercept. I get that from this number here. And then my slope is the coefficient of x, which is -3. My slope is -3, not -3x. A lot of times people will try to say, oh, the slope is -3x. This is not true. The slope is just -3. So that's important to remember. Okay, so my slope is -3. So that means this goes down 3 and over 1. And down 3 and over 1. And so now, when I plot this line, this looks a little tricky here. My point of intersection is right in the middle there. So that means my solution is x is 1.5 and y is -2.5. Now that's what that looks like to me. Let me see if I can zoom in here a little bit. Make sure that's what that looks like for you. Does that look like that's right in the middle? I think it certainly looks very close. Sometimes though, we need to be careful because we're trying to be precise, but I am just eyeballing this with a ruler. So this is going to be a good one for us to check our work. Okay, so I'm going to go about my business now of checking my work on this one. So to check, I'm going to have my y value, and that's going to equal -3 times x plus 2. I'm checking this equation first. It doesn't matter which one you check first, but this is the one I'm going to try. My y value is -2.5. My x value is 1.5. Simplifying, that's going to give me -2.5 equals. Now 3 times 1.5. If I had $1.50 and 3 different friends gave me $1.50, how much money would I have? I think that's going to be $4.50, or the same as 4.5. And then don't forget that there's a negative there, so I'm going to have -4.5 plus 2. So on the left here, I have -2.5. And on the right, I have -4.5 plus 2. So when I add 2 to this value, I get -2.5. Well, it certainly works for the pink line. Now let's check this dark blue line. For this side, again, I'm going to plug in my value for y. So y equals 1/3 of 1.5, oops, minus 3. I meant to do that in pink. Sorry. I'll put the y value in pink here. So this is -2.5. So simplifying now, this side is going to be -2.5, and 1/3 of 1.5. So this would be like $1.50, and we're going to divide it by 3. That's what the 1/3 means, is just dividing by 3. So if I had $1.50, and you and another friend of ours and I were going to split it 3 ways, we would each get 50 cents, or 0.5, and then minus 3. Well, 50 cents minus $3, that's going to be -2.50, and that equals -2.5. So that checks. And you'll have to forgive me for the money. Sometimes that's just an easier way for me to think about those fractions. is by comparing them to their monetary values. So that means our solution is correct here. Even though this looked kind of tricky because it was here in the middle and that involved some decimals, turns out they weren't that bad. And our solution is 1.5 for x and negative 2.5 for y. Let's do one more example. For this example, again, I have y equals 1/3 x minus 3. That's this dark line here. And I'm going to compare it to y equals negative 4/3 x plus 2. So let's look at where that is. My y-intercept is going to be at positive 2. So I go here to the origin and go up 2. That's my y-intercept of positive 2. And then the slope is negative 4/3. So I'm going to come down 1, 2, 3, 4, and over 1, 2, 3. Hey, look at that. And then just to draw my line, I'm going to do it again. Down 1, 2, 3, 4, and over 1, 2, 3. Then graphing that line. Can you see the solution already? It looks that our solution is right about here, which would be at positive 3, negative 2. So to check this, sorry, it looks like the ink is shining into the camera there a little bit. To check this, I need to plug in those x and y values. So I'm going to start with, and again, it doesn't matter which one I start with. This time I'll start with this one, just to show it really doesn't matter. So I'm going to have my y value, and that's going to equal 1/3 of x minus 3. In this case, the y value is negative 2, and the x value is 3. Simplifying this, oops, there we go. Simplifying this, that's going to give me negative 2 equals 1/3 of 3 is just 1 minus 3. That means negative 2 equals negative 2. Look at that. It worked out. Okay, so now what I want to do is check this one. You have to check both. Okay, so checking this one, I've got y equals negative 4/3 times x plus 2. Plugging in those values, y is negative 2 and x is positive 3. Simplifying that now, I'm going to have negative 2 negative 2 equals, now this is negative 4/3 times 3. Well, this is divide by 3 and this is multiply by 3. So I'm going to cross these out, but I'm not going to say the word cancel because 3 divided by 3 is 1. So this is negative 4 times 1. Negative 4 times 1 is just negative 4. And then plus 2. So on this side I have negative 2, and then negative 4 plus 2 is negative 2. And they both work out. So that means that this point here at 3, negative 2 is the solution to this system of equations.